Okay, now that we've talked about confidence intervals for proportions, we're going to talk about confidence intervals for means. So a population's confidence interval is usually built around the point estimate. That's what's obtained from the sample. For the population mean, the sample mean, which remember is x bar, and the confidence level will be from x bar minus e to x bar plus e, and we'll talk about how to find e, and we'll also be able to use this doing our calculator. So we're going to have two different ways to do this based on whether we know the population's standard deviation sigma or not. So if we do know the population sigma value, then we use what's called a z interval. And here's the formula for E, but again, we can take E minus, the upper value of our interval minus x bar to get our E. So the question here we're going to answer is, what is the average credit rating? So it says find a 90% confidence interval for the average FICO credit scores of adults applying for credit cards. So the sample information says we collected a simple random sample of 70 adults who are applying for a credit card. The mean rating of these 70 adults, so x bar, was 688. The standard deviation of the credit rating for the entire population was 68. Okay. So we're actually not going, so remember, so the mean is still just the mean. And remember, the standard deviation, we're picking more than one person, is the standard deviation divided by the square root of n. And that's where this part of the formula comes from. So the point estimate for our sample size is the mean, or for our sample, so 688. Now to get our margin of error, we can actually do this on the calculator by going stat over to test and choosing z interval, which you can see is number 7. So we're going to leave it on data at the top, we want to go to stats. So for sigma, we're going to put in the sigma they give us, so the 68. We're going to put in the mean they give us was 688, and the n was 70. And we're told we want to find a 90% confidence level, so we're going to change that confidence level to 0.90 and hit calculate. Okay, so here's our interval. Now to find our E, so we're going to write our interval here, 674.63 to 701.37. Find our E. Remember, we can take that upper value, the 701.37, and subtract our x bar, 688. So our E, we find, is 13.37. So another way we can say it, we can say we are 90% confident that the average credit rating of credit card applicants is 688, is the mean, x bar, with a margin of error of 13.37. However, there's a problem. In the real world, if we're trying to determine the population's mean, we're not likely to already know the population's standard deviation. We can't use the sample standard deviation because it's biased. So we have to do something a little bit different. We're going to use what's called a T-distribution. So the critical values for T's are always bigger than the corresponding values for Z's. So we're going to use this when we don't know the population standard deviation, when we're not given sigma, but when we're given little s. So we're going to use our calculators to do this too. This is going to be a T interval. You're going to find it the same way. We're going to do stat, go over to test, and do T interval, which I think is down at number 8. Okay. So number 1 says we want to find the mean length of men's forearms, so from elbow to fingertip, with a 99% confidence level. Here's the sample information. It says we measured 32 men's forearms. The sample mean X bar was 14.5, so we're going to put that here. And the sample standard deviation S was 0.7. Use your calculator to find the confidence level. So our N here was 32, and we want a 99% confidence, so we're going to put 0.99. So we're going to do that t-interval. So we're going to just put this information in, 14.5, 0.7, 32, and 0.99. So here we would see that our confidence level is from 14.16 to 14.84. So we can say we are 99% confident that the mean length of men's forearms is between 14.16 inches and 14.84 inches. Or alternatively, we are 99% confident that the mean length of men's forearms is 14.5 inches. And so remember, to find our our margin of error, we can take the upper value, 14.84, and subtract the mean, 14.5. So our margin of error is plus or minus 0.34 inches. We're going to do another example here. It says in a sample of 40 Choco Chunk cookies, the mean number of chocolate chips was 22.7, so that's our X bar. And the standard deviation was 3.2, so that's our SX. Construct a 95% confidence interval for the mean number of chocolate chips and such cookies. So our N was how many we sampled, so that's 40, and our confidence level is going to be 0.95. So again, this is going to be a T interval. So we're going to go stat, over to test, choose number 8. So we're going to put this information in. So we're going to hit calculate, and we see that we are 95% confident that the mean number of chocolate chips is between, we're going to round to one decimal place, 21.7 and 23.7 chips. Now, the nice thing is our calculator will actually do everything for us, even if we're just given a list of data. So we're going to do an example here. So it says, what's the average pulse rate of statistics students on the first day of class? So it says our sample information will be the pulse rates of 15 random students taken at the beginning of the semester. So there we have those 15 values. We're going to go to Stat and Edit. We're going to clear L1. And we're going to put in these 15 values. Carefully. Okay, so first we need the point estimate, the standard deviation, the confidence level. This is going to be a T because we don't know the standard deviation of all students. Now the good news is the calculator will actually kind of do this in the background. You don't need to find it right now. So we're going to go to Stat, over to Tests, and we're going to go down to T interval. And instead of choosing Stats, we're going to choose Data. So since we put everything in L1, we're going to leave frequency at 1. It's going to do everything for us. So we wanted a 99% confidence level. Or at least that's what it says down here, so that's what we're going to use. Notice if we hit calculate, it will tell us that the point estimate here is 87.9 and the sample standard deviation is 16.1. And our confidence level there at the top is 75.47 to 100.27. Our margin of error we can take by doing, remember the upper bound, the 100.27, and subtracting our point estimate, 87.9. So we have 12.37. So we can say that we are 99% confident that the mean pulse rate of all statistics students on the first day of class is between 75.47 and 100.27. Or we can say we are 99% confident that the mean pulse rate of all statistics students on the first day of class is 87.9 with a margin of error of plus or minus 12.37. Now, just like we did with proportions, we can find the minimum sample size needed. So here's our formula for n. The z is going to come from the formula sheet again, that critical value. So our problem here says we want to estimate the average IQ of all students. Planning ahead, we want our confidence interval to have a margin of error of plus or minus 5, so that's our E, and a confidence level of 99%. So our minimum sample size, and we're given our standard deviation. So our n here, we want z alpha over 2 for 99%. So we're going to go to the formula sheet and look at that critical value for 99%, which is 2.575 times sigma times 15 over the margin of error, which we wanted was 5, and that whole thing squared. So we're going to do that on the calculator. 2.575. Since we're squaring at the end, we will need to put parentheses around the whole thing before we square it. So here we'd get 59.6. And remember, we do always have to round up to the next number, so we have to sample at least 60 statistics students.